Okay, page 4.
Technically, yeah, that's what we're doing.
Okay, page 4. We did do examples 1 and 2, right? Limit definition. Okay. I want us to go through 3 and 4 using the general limit definition. I know some of you guys are coming from AV calculus, and so you already know how to do power rule, but I want us to stick with the general definition for a little bit longer because I want to show you what an AP exam question could look like. That's forcing forcing students to have knowledge of these 2 limit definitions, and power rule is not going to help you if you don't know how to interpret it. So but I want to have us get a little bit more, just get more practice with limit definition, and then I'll show you how College Board can kind of mix things up in a way where we have to be able to know how to interpret it. Okay, so with number 3, we're going to go through general definition here. So let's build our f of x plus h for this particular function, and we'll insert it into our numerator expressions, and then we'll just treat it like a limit problem where we're doing direct substitution, but we're expecting a whole, and we're trying to find a way to cancel the h's out. Okay, so try that. So we did 1 and 2. So now let's try 3 and 4. So hopefully you guys all picked up the handout. This is 2.2b, which is basically interpreting the definition of the derivative in a different form than the way that we've been doing here. Okay, so make sure that we're putting our x plus h in the correct spot. So the way to ensure that, rewrite your original function, leave an empty space or a reserved parentheses where the x was, remove the x, and in place of it, put an x plus h. Now, just treat it like a limit problem, right? So direct substitution, we get 0 over 0, conjugate method gets that radical to resolve. Expand. The numerator cleans up nicely. Just make sure we remember to protect that second set of terms with a set of parentheses, so we can remember to distribute through. but ultimately we're hoping that an h will appear up top so we can cleanly cancel those out. Should be 2 at the bottom here, right? Do you guys get 2? Okay, sorry. So in the end, we'll get root 5x plus 2 plus root 5x plus 2. There's 2 of them here, so there's 2 radical 5x plus 2. Right, try number 4. Right, everybody good with 3? So 3, we have to see the need for common denominators, but first let's make sure that our x plus h is put in the right place. It's going to replace the x in the denominator, so that x plus h is going to be completely in the denominator. Okay, sure. Oh, there's a handout.
Is it on the website?
Yes, it is. Yeah, oh, that's right. You use online. Okay, so we confirmed that 0 over 0 is there's a hole in the graph. Common denominators required for that upper portion. So our common denominator is both the x minus 2 and that x plus h minus 2. Balance our numerators, protect the second numerator with a set of parentheses, distribute through. But ultimately, we're hoping that an h will pop up above. Once it does, bring that denominator h up as the reciprocal. Remove the h, reevaluate, and then we get to our derivative function, which will represent the slope formula for whatever the original graph looks like. So it's a tedious process, but once we get to the setup, then it's just a limit problem that we know how to do from the first unit. But now I want us to talk about this limit definition that's going to force us to look at it a little bit more closely, especially when we're halfway through the problem. So I want to present another full problem to you from beginning to end, and I want to kind of pick apart where College Board is going to so the College Board problem could look like where they will select a portion from the limit definition and ask you what's going on, or what is, how do we get to this point? Any questions with 4? Are we good with 4? Okay, so give you guys another moment here, and then I want to show you an example from scratch. Okay, very good here. Okay, so you guys don't have to write this down, but this is something very similar to what we just did. But I do want to kind of walk us through a problem, and then I want to show you where things can be picked apart. Okay, so first, let's say we want to use limit definition to find the derivative, and from the derivative, we'll evaluate the derivative at 1. Okay, so here's the process, right? We build our f of x plus h. So initially, our f of x was 5x squared minus x. We have a set of parentheses for the reserve spot. We go ahead and we put the x plus h in place. Okay. Here's my f of x plus h minus f of x all over h. And then, okay, I'm going to put a box around this because we're going to revisit this after I get down to the end. Okay, but from here, we go through our limit procedure, 0 over 0, evaluate, reduce, and then we get all the way down to f prime equals 10x minus 1. Okay. All right, so are we good here? Okay. So I want you guys to follow along. You don't have to write anything down. So I want us to understand that this f prime is the same as this f prime, right? So this represents the slope formula of the function, even though we will never use this, right? We would much rather use this because this is a lot more efficient. But this, I want us to understand this does represent the derivative formula of the graph, right? Okay, the slope formula. Now, what if I asked you to find the slope at 1? Then it would look like this, right? You would evaluate the derivative at 1. You would plug 1 in and you'll get 9. And that 9 represents the slope of this graph, the slope of this parabola at x equals 1. Okay, whatever the slope of the graph is, that whatever the graph looks like, that is the steepness of the graph at 1. Okay. So if you were given this and you were only shown this portion, would you be able to pick out where this function is coming from? And how would you go about doing it? Yeah, the 5x squared minus x, right? It's pretty easy to tell, right? That this is coming from that function. Now, what if this wasn't showing? Would you be able to pick it out from the first portion? Yeah, you would know that the x plus h is coming from the x, and then you can kind of piece it back together that this must be coming from 5x squared minus x. Okay, so we're good there, right? Now, what if I wanted to find the slope of the graph, but I wanted to replace all the x's with ones? What would that look like? That means I'll just replace every x with 1, and it will look like this. Every x gets replaced with 1, so this is the same thing as this. Okay. So the question is, if you saw this, would you be able to know what this is referring to, what function is coming from, and what this is trying to do? Okay. So this is how we would go about doing it, right? We know that 1 plus h is coming from x plus h, which is coming from x. So just by this, obviously we're not going to get any help from this, right? This is too far simplified, where we're not getting any structure for us to figure out what the function is, but we can still figure out what the function is here, right? So this is telling us, okay, we're talking about a function 5x squared minus x, and we're asking for the derivative at that point for this function. Okay, so that is what a College Board problem could look like, where they give that to you and they ask you, what does that mean? Okay. So we can say, well, we know that this function is coming from 5x squared minus x, and because of the x getting replaced with 1, we know that this is representing the derivative of this function at 1. Okay. So even if we know power rule, if we don't, and it's not asking for you to find the slope, it's just asking, what does this represent? Okay, so any questions there? All right, so today we're just going to practice with that. If I gave you a whole bunch of limit expressions, can you pull what the function is coming from? And can you understand that it's talking about the slope at a particular point, or the derivative at a particular point? So I think the limit definition of derivative is a little bit harder to pull that information. I think pulling this information from the alternate definition is a little bit easier. So let me just walk through the steps for alternate definition and then show you what that looks like. It's a little bit easier to pick things apart though. So again, no need to write this down. I just want to kind of walk us through a limit problem, the alternate definition. So this alternate definition, we talked about how the difference here is that this will still do the same thing as the general definition, but it won't stop midway at the derivative formula. It'll take you directly to the slope value. So, so here I have my derivative function written out. We said that the first thing we do, if we want to use the alternative definition, is go ahead and replace all the c with whatever x value that you're concerned with. So replace every c with 1, and then it becomes a little more clear that we're trying to find f prime of 1. And then we just have to do our work to replace the numerator. F of x is the original function, so that gets replaced with 5x squared minus x. F of 1 is just evaluating the function at 1, that becomes minus 4. And then I'll put a box around that because we'll come back to this form later. But if we were to go about from here, we know that, okay, this will give us 0 over 0. We factor, reduce, and we get all the way down to f prime of 1 equals 9. It's the same function as the one before, but we're just going down a different path. So if we were to look at this without that f prime of 1, will we be able to tell what function this is coming from? Right, this is easier, right? Because the 5x squared minus x is not as messed. It's not changed as much as the general definition. So we know that this is coming. If you see this notation, you know, okay, this must be coming from 5x squared minus x. This is asking for the derivative of this function at 1. So it's not as hard for us to decipher that, right? Because the alternate definition kind of keeps that numerator a little bit easier for us to interpret. So we know this function is referencing that 5x squared minus x, and this represents the derivative of this function at 1. So that's what I want us to do today. Can we look at a limit definition that is worked halfway through, and can we pick out what function is coming from, and can we understand that it's asking for the slope at a point? All right, so let's go to the new review here. Or sorry, new worksheet here. So it says identify the function you're working with, then identify the x value for the instantaneous rate of change or the slope of the tangent line at that point. So you see that this is in the form of this general definition. And we know with all the numbers replaced that this is asking for the slope at a point. But we're not going to get much help from this f of x. So we're going to have to decipher the function from this first piece. Can you put it together and guess what is the function that got us to this point? So this 4 plus x is coming from x plus h, right? Sorry, 4 plus h is coming from x plus h. And then I can put that x plus h back with what? With just x. So what's my function? 5 natural log of 2 over x. That's the function. So if we were to build the limit definition from scratch, it would eventually get to this point. But you see the x gets replaced with 4. So therefore, this is asking for the slope of the graph at what point? At x equals 4. Yeah. So this is the notation for f prime of 4. This is saying, given this function, what is the slope of the graph at f4? So just to show you what this would look like if I were to build this from scratch. Right, if this was my function, this will be my f of x plus h minus f of x all over h. Replace every x with 4, and that will take me to what this is referring to. So this notation represents f prime of 4, which is the slope or the rate of change of f of x at 4. Now, we will never work a problem in this form. We just need to be able to, recognize what this is referring to if this was a multiple choice question. Okay. I think the alternate definition is a little bit easier to pull that information from here. So for number 2 here, this is in the form of this alternate definition, right? We know this represents f prime of some value. What's the function that this is coming from? This is easy, right? It's just whatever that first term is. It's not as manipulated as the general definition. So the alternate definition is easy to pick that information. And then we're asking for the slope of this graph at what point? Yeah, that's easy as well, right? X approaching pi over 2. So we know ultimately it's asking for f prime of pi over 2. If I were to go through the steps from the very beginning, that's what it would look like anyways, right? So okay, so why don't we try the bottom half and see if you're able to look at that the weird notation that they have and see if you can pick out what function is it coming from, and then what is it asking you to, what does it represent, right? They all are going to represent the slope at a point, right? Okay, so go ahead and try the bottom portion there, 24 through 26. I think what you can do is you can just look at the form and instantly tell whether it's coming from the general definition or from the limit definition or from the alternate definition. Okay, so try those 3 and then I'll walk through them with you. Okay, so I think with this setup, they're trying to make it a little easier for you to see that function. They could have put the 1 + 3 and added it to make it 4, but that would have been more mean because you can't really understand, like where's that coming from. So just understand that the last number is going to be with the f of x, and so your function is going to include that 1. That +1 is part of your original function. Okay. So they're separated that 1 and 3 so that you can more easily tell that the 1 is with the first part. Okay, so what function is this coming from? Yeah, that's it. That's the hardest part, right? You can pull that information, then that's great. And then it's just asking for f prime of 1. Okay, 25, what's the function that this is coming from?
6 for sin x.
Yes, it's like 6 for sine x, and it's asking for the slope of the function at pi over 2, right? So the ultimate definition is easier to pull. Just the general definition looks a little messier, that's all. The bottom there, I just wanted to show what it would look like if I were to start from scratch and work my way to f prime of -5, which just want to convince you that the messy notation just represents f prime of -5. Yeah, so
Anything pages with together, you just replace it with x.
yeah, that's right. Anytime there is a h with a number, you can just pull that out and know that it's replaced with x. Yeah, yeah. But you know that because there's a number instead of x, that is not just a slope formula. It is the slope at a point. So they're putting all that into the expression to see if students can put that together. Yeah. Okay, so go ahead and try the second page and see if you can get through 27, 28, and then read 29 through 31 and see if you're able to make sense of that as well. And I'll go over each with you, but want to have you guys attempt them first. All right, any question with 27, 28? Okay, 29. Let the function be defined by f of x equals natural log of 7x. The average rate of change over the interval from 2 to a is 41, where a is greater than 2, which is the following equation could be used to find the value of a. So the definition for average rate of change is just the slope between the endpoints of the original function, just basically y2 minus y1 over x2 minus x1. So see if you can use basically building your slope formula and then figuring out which option would best fit the information given. Okay, 30, same way. F y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Okay, so number 30, f of a minus f of 1 over a minus 1. F of a replaces all the x's with a. F of 1 replaces all the x's with 1. Now, this second part, we can actually clean up a bit more because we know natural log of 1 is 0. So that's going to wipe out that entire second term. So we're just left with sine a natural log of a all over a minus 1.
It has to be continuous.
Exactly. Yeah.
But if something continuous, it doesn't.
Does not have to be. Yeah. Sharp turn could. Yeah. Sharp turn is continuous, but not differentiable. Okay, good. 31. Take a look at 31. See if you can decipher that. It can't be, yeah. If it's differentiable, it needs continuity, yeah. Okay, so 31. Basically, we have to figure out what f of x is, right? What's f of x from this expression? X squared, right? So if I can replace f of x with x squared, then I can just solve for x. Technically, it's plus or minus 2, but we just choose the option that works. Okay, any questions? Yeah, that's all.